Hello, teachers. Thank you for viewing this short slideshow presentation on Distance Learning. We're glad you're here. Let's take a few moments and look at this ladybug. Scientists believe that true flight is shared by insects, birds, and bats. Some animals can soar, but that's not the same thing. They also believe that the development of flight was related to the size of the animals. Are they big or small? What do you notice? What questions do you have? You or your students might say, there's 2 pairs of wings, or I noticed it started to fly forward and then it went up. How does it stay balanced? How does it change direction? And why? Why does it need to fly? You can launch a lesson from here. With a little direction, students will create their own learning targets. Most likely they'll be what you had in mind in the first place, but they may be deeper than you expected. And the thing that's cool about at-home learning is that students can go out and find the ladybugs. We know that teachers and leaders want to support science instruction during temporary school soft closures due to COVID-19 or for any other reason that comes up in the future. We want science instruction to remain effective, meaningful, and aligned to state standards to support continued learning. We also know that there are issues with unequal access to technology and diverse affective or emotional responses to learning at home. Some kids just really want to be with their friends and with their teachers. So, for the purposes of quality distance learning, please consider inviting students to participate in activities that focus on science and engineering practices with Phenomena as a starting point. Educators should try to leverage the assets of home-based learning rather than trying to recreate school. We can provide meaningful science learning experiences that connect to students' home lives, interests, and identities. Trying to support school-like learning in a home setting may frustrate everyone. We should consider the resources that are available at home. We want science to be a verb, and we can by thinking about the science and engineering practices and cross-cutting concepts that are part of the SEED standards. Of course, we also want to talk about phenomena. Phenomena are observable events that occur in the universe and that we can use our science knowledge to explain or predict. The goal of building knowledge in science is to develop general ideas based on evidence that explain and predict phenomena. Phenomena are the basis for solid science learning, and we can help our kids do that at home. There's things they have at home that they can use. Foam from soap, shaving cream, whipped topping, opening a soda can. Foam is usually 95% gas and 5% liquid. What can we learn and talk about there? Ice. Why is it slippery? Scientists actually do study this in a lab even right now, today. The surface tension with breakfast cereal would be a great thing for your students to notice. Magnets. Even if you don't want them, you have them in your house. Our students will too. Can the students make and show static electricity? And ask questions. Why do electrons flow from one object to another? Could they look at a bowl or a package of peanuts and talk about and think about why the big nuts are on top and the small nuts and the pieces are on the bottom? And of course, there's everything that's outside. Rainbows, clouds, wind, soil, rocks, plants, animals, so many things to notice, and not just see, but to smell and hear and feel. Those are the types of things that we want to focus on, but we also want to think about how we can set it up so that it's student-friendly. First of all, we want our students to have a flexible schedule, and we, of course, like we've said before, we want to pay attention to make sure that we provide for our students that have limited technology access. Students should be engaged in meaningful science explorations, investigations, or sense-making. And we want to make sure that our students have choices with how they engage, what they engage in, and how they can demonstrate their learning. Can they label a picture that they took? Can they label a picture that they've drawn? Can they make a list? Can they gather data and analyze it? We want students to really engage in self-reflection, not just about what they're paying attention to, but also the process that they've been going through that supports their science learning. This also reflects standard-based grading. Students are engaged in science and engineering practices that are part of the standards, and you'll have evidence of that. We want to make sure that science learning is connected to what happens at home, related to problems they might have, cooking, fixing things, gardening. Ask students to identify things that are happening in their house and engage in the design cycle to address them. How could they make their morning routine better? How could they load the dishwasher so they can get the most amount of dishes in it and they still get clean without having to wash the extra ones by hand? How would an open window make a difference with how many times they have to dust the furniture in a week or a month? Letting students explore problems and phenomena that are of interest to them and right under their nose really helps them build their understanding of the world. And it helps them with their science practices over time, especially when we have them observe plants or animals or phenomena that they find outside. Science lessons should be easily adaptable for both online and printed formats. It needs to be easy for you to give them. The science experiences can be designed or modified so that students get the work maybe at the beginning of the week, get the ideas from you, and then they can write up their observations, their inferences, solutions, and then return the work to their teacher and report, kind of like reporting back. The idea would be that we would give students 1 or 2 science or SEED type tasks or activities a week. This aligns with the expectations and the vision for SEED because it gives students a time to investigate and explore and understand their work better. There's a simple template that was created by the Utah State Board of Education. It's 4 pages, and you can use it in your Google Classroom or printed for student learning in a distance situation. It starts with this. Now, the template was created in Google Slides, so you could use this template for lessons and ideas that you have and then upload it to your Google Classroom, or you could just print out the slides and include it in packets for students that don't have access to the technology at home. First step, this slide, is about asking questions, noticing, and making observations. You could include an image, a graph, a chart, or give them something to go find outside or in their home. The next step is helping them find out ways to explore. This would be to plan and carry out an investigation. You could give them outline or a task, or you could let them decide how they want to understand the phenomena, because that's really what it was, better themselves. And of course, then they explain what they understand and how they feel about it too. What are they thinking? The third step, or the third slide, is about research, analysis, and interpreting data. So you could give them some reading, give them some websites, additional information where they could gather information about the questions that they still have. And of course, we want them to write an explanation that's based on evidence. The last slide, step 4, is about constructing explanations, evaluating and communicating information, and engaging in argument from evidence. Students can make connections. Have they seen something like this before? How is it different? How is it the same? And then students need to share it with another person. Just talking, email, writing, being on Zoom with their grandparents, and say what they have learned about. All of these are science and engineering practices. So using this template, this format, could be something that you could do with your students that is manageable for you as a teacher. It provides evidence that your students have met the standards, and it might be something that they enjoy. Now, we know science learning at home is not school as usual. We know we want students to use things that they can find at home that interest them, and we know that there's a general format or an outline that we can follow. We can give students 1 or 2 assignments a week. Where do we start? What resources do we have that are reasonable to use? You probably do already know of a few. The next slide will have resources that can be adapted to support students' learning in this format. We have not included online resources that are online only or online or video watching intensive. We really want students out and about and observing their world, not just stuck with a screen all day. So the first idea would be to have your students take a notice and wonder walk. The purpose would be for them to just get outside and really notice the details of the world around them. Ask the questions, the hows and the whys and the what's going on. And this can be adapted for any students at any grade level. The directions and expectations for the assignment, of course, are in the Canvas course if you would like to do something like that. Another resource that you could use is from NGSS. They have a website with distance learning lessons ideas that are phenomenon-based. You can use them as idea starters for your own lessons, or you could use their virtual examples. Another cool thing about this website is that you can sign up for a weekly phenomenon email, just to keep it fresh. You may have participated in Project Learning Tree Training or used their activities before with your class. This website specifically has activities that students can do at home. So they would be great lesson idea starters for you. Another resource is the Exploratorium. They have hybrid lessons where they have some online and then offline activities. You could check them out and see how you could adapt them for your students and the SEED standards for what you're teaching. You could also give students a challenge or a bingo card of activities. This is one from NGSS that encourages investigating and inferencing skills. If you give something like that, though, please be careful to give students meaningful work. We don't want to give them things just to keep them busy. One of the best resources that we have is the UEN Learn at Home website. They do have science lessons for every grade level that have already been created by a team of teachers based on the template that we reviewed just a few minutes ago. So, if you need to, you can download those lessons and then upload them to your Google Classroom or print them from your students. They really are created as kind of like standalone pieces, so there's not a lot of work that you would need to do, and those are set there and ready to go. They also have general science and STEM resources available, and Utah or place-based ideas if you really want to focus on the environment that's around your students. One cool thing about this website is that they have some resources created by the informal science educators in our state. So the zoo, the aquarium, museums that usually do outreach with our students, of course, can't do it right now. So they've created some lessons that we can give the students, along with there's a few virtual tours and things like that you are welcome to use. You could use these resources or others. You could put them in the lesson template or whatever format really meets the needs for your students. Please remember, though, to keep them active, keep them noticing and sense-making, just engaged in the world that's around them. I hope this information and resources are helpful. Please contact me if you have any questions. I would be glad to work with you. Have a great day and stay healthy. Thank you.